Hello students, in this video we shall introduce a very important and advanced topic of Java that is called as collections. Collections are basically a framework in Java language. So Java says that there are a lot of data structures which are needed in order to keep objects within them, and they can be operated also once they are stored into different types of data structures. So in fact, if we go to study data structures in Java, so collections will be the framework that we'll be needing. And this collection framework, and what exactly is meant by framework? Framework, basically, it's a collection of some classes and some interfaces. Interfaces, now that you know that, and we had explained in the earlier videos, you know what interfaces are. So there have been certain inbuilt interfaces, there are certain inbuilt classes which are stored in the collections framework, and those classes are actually the classes which we will be using in order to explain data structures. So we know, if you have theoretical background of data structures, you will actually understand by meaning of what exactly the classes or the data structures are. Your data structures are collections of your data plus the operations. We actually define data first, and then we define the operations that can be performed over those data structures. So like, for example, we are having a stack in which we say that stack is a collection of some data, and there can be two operations which are push and pop, which are defined. So like stack is defined by some push and pop operations. There are other data structures which actually define how the data is stored within the memory and how the different operations can be done over that data structure. These all things are simplified in Java by making use of a collection framework. So you will see that all these classes which we'll be using in order to use certain data structures make use of certain inbuilt methods, because they are actually confined to the one interface. So because there is a separate one interface which is implemented by all data structures, so there is the same category of methods which will be working over different type of collections. For stack, there will be like different methods which are needed. We'll see how different data structures are done. In fact, let me give you a list of the collections that we'll be seeing in. We'll be seeing your ArrayList, we will be seeing your vectors, we will be seeing your linked list, we'll be seeing your stacks, and we'll be seeing your maps too. In fact, we can also see the sets. So there are multiple versions or some derived classes of all these classes too, which actually define new type of data structures. Like from map, we can get hash map and tree maps too. So in fact, from set 2 we can get HashSet, and we can get TreeSets out of this collection. So there is a long list of collections which are actually available in Java. We'll not make use of all, but I'll try to explain major of the collections, and we'll try to show you how different kind of data structures are actually used, the data operations and their implementation. So let us see them one by one. All these collections, they are stored within this util package. So you need to import this package before we make use of any data structure. So like I make use of ArrayList. So ArrayList is defined like this. We'll make use of this entangled operator. This entangled operator is actually says that this is a generic class. So this ArrayList is basically a generic class. What exactly is meant by generics? In C and C++, we had seen it was named as templates. So now in Java, we say that it's the generic class. By generic class, it means that we can create an array list of a different kind of objects. So it will depend upon the type of object that we pass on right here. Like for example, if I pass on an integer here, so your array list object would be of the type that it will be storing integers only. You can have an array list of strings, you can have an array list of doubles. One thing to be remembered is that we'll make use of only wrapper classes. You cannot write int here. We'll not be writing int. We'll be making use of integer wrapper class, because this collection is a collection of objects. So going back, I'll write integer here and a name of ArrayList. Suppose I name it as AL and pass on as new ArrayList. Again pass on integer as a generic name, and then followed by the constructor. Now your collection is ready and your data structure is ready. Now that the next thing is how to add the new elements into it and how to perform operations over that. So there is an add method that is available here that will be making use in order to add new elements into it. So like for example, if I say al.add and I pass on one integer 1, and then I keep on using this add and putting the elements into it. Likewise, you can add as many integer elements. So you must keep into the mind that we can only input integer values here. Now, once all the elements are added, you can see the nature of this array list. So what happens when I try to print this? I try to print the whole collection. So let us see the first experiment. See the output of this fragment only. Let's compile this program. Let's run it. You'll see that the output comes in that shows that the output of one array list data structure. Now what this data structure is, this array list is basically different from normal arrays in Java. Why it is different too? Because here we say that it's a dynamic array. What exactly do we mean by a dynamic array? Dynamic array means that its size can be varied. Like size, earlier we say that an array, like it was created, like let me show you how an integer array was earlier created. It was created like this, and we created an array like this. So just see the difference. In this way, we are creating an array and we are giving a fixed size like 10 here. So we can store only 10 elements into this array of integers. Now within this array list, what's as possible is you can keep on adding as many elements. There is no size limit. So the number of elements which will be present in the collection, that will be the size of that array. Even once your elements are stored within this array list, you can remove certain elements. Like for example, what I do, I say al.remove and give the index into it. Now after removing one element, let me show you the output. Let us print the array like this too. And the next very important operation that is needed, that can be needed in any kind of a data structure, is how you can actually access all the elements. So in order to access all the elements one by one, we may use a get method out of them. So I'll use integer I is equal to 0, starting index is 0 and I less than. So how could I know the size of this array list? There is a method that is called as size. So it's a method in the ArrayList collection. It goes till that and goes on to increment this I, and then we can go on to print all the elements using print function, and then I make use of another method that is called as get. So I'll make use of I. So this can actually remind you the char function of string that we had used. So we could not actually use square brackets in order to access elements. Right now in array collections too, we cannot use the indexes in order to access all the elements. We may actually have an access to the method that is get. So let us see the output of this fragmentation. Compile and then run. You'll see your first output says that this is the complete list that you had just created, and then once you remove the element at index 1, the 2 was removed and the remaining elements were printed, and then you actually printed all the elements remaining one by one. That's why it printed 1 and 3. So because there was no space written within that, that's why it is showing 13. Otherwise you can have a space within that and all the elements can be separated. Compile and run. You'll see all the elements can be printed. Now this is how we deal with array lists. Now let's change it to linked list. I just am changing the list to array list from linked list. I am not making any changes into it, and let us see how it, whether there is any change that is required. So let us compile the program and run the program. I show you the similar output. So you may actually be surprised at seeing that even if we have changed the data structure, the output of the program is still same. Why? Because the linked list and array list, they are different in the way the elements are stored in the memory. Your array list and your linked list. Your array list is a contiguous in memory, and whereas linked list is non-contiguous. Non-contiguous means its elements can be stored at different locations. You know that in linked list the elements are actually stored within their addresses. So every element is having the address of the next element. So they are called as nodes. So each node that contains the address of next node. Right? So that implementation is hidden from you, and this is perfectly implemented in the same way as ArrayList. So you need not worry about how internally the elements are stored and being accessed. You need to just make use of these methods like add, your remove, your size, and this get. These four are very important methods which actually you can make use with respect to any data structure, and they will be similar one. And this is because these methods are available within the interfaces which are actually implemented automatically by these data structures. So let me show you another example of a stack. What if, and before stack, let us see one more data structure that is called as vector. Let us convert it into vector and let's see what happens. Change the data structure without changing anything in the program, and I'll see that it is saying it is vector list. Convert it into vector, compile it again, and just run it. I will see the same output. You know, this vector, linked list, and array list, they look like similar through the program, but internally they are different. So how vector is different to array list? So vector and array list, this is a very important question asked in the interviews, that define what is exactly the difference, because array list and linked list, they are non-contiguous, or they depend upon how the elements are stored, but how the vector is different. So they are actually defined with the way they are accessed or operated using threads. So it is array list is called as synchronized. It is called as synchronized data structure, and it is not synchronized. What exactly do we mean by synchronization and non-synchronization? Suppose there is an object. Suppose this is a list of elements. So I stored 1, 2, and 3. Now what happens is, inside your memory, this array list can be accessed by one or more threads. One or more threads means more than one processes at the same time. Suppose this P1 process is trying to access element one by one from this array list, and this P2 process at the same time it is trying to delete this element, and this P3 element is actually trying to access the last element. Now what actually will happen in, will all these processes can work in parallel on this array list? It says that array list is synchronized. It means that if multiple threads tries to access this array list in the memory, they will be given access one by one automatically. You will not be allowed to operate this array list before P1, P2 until this P1 process is complete. So once P2 is working over this particular array list, no other process can work over that. It is meant by synchronization. So array vector in comparison is not synchronized, means all these processes, if a vector is being processed by multiple threads, so they can actually try to work over the same vector at the same time. So but in that case, your output might be different with respect to each and every thread. You will yourself have to see how you provide an access to all these processes in case your data structure is vector. So your ArrayList is very much memory safe because the operations are synchronized, means one by one, and vector are not very rarely used because of this nature of not synchronization. Let us see now how stacks are operated. Now stack in comparison has two new methods. Now for example, I convert this vector into stack. Now once this is a stack, we can make use of two very important methods. We know that a stack is created by making use of push methods. So the elements are added into stack, make use of push method. So we'll be adding all these elements one by push. So push makes this stack as a last in first out kind of a data structure, because the last element that will be added at the last will be popped first. So let me actually pop an element, and without removing, I'll say system.out.println here.pop. So let me pop an element, so that will be printed, and then after that I just let it remain. You'll see the output as it is. Let us see the nature of push and pop into this. So let us run this program. You'll see that what happens. Earlier, the stack was having 1, 2, 3 as an element. The 3 was the last element which was pushed in. So once you tried to pop an element from this stack, the output was 3. So once that element was popped, so this actually meant by it will take an element out and that element will be removed. So the stack was left with only 2 elements. So once you iterated all the elements, it gave you 1 and 2. So this is how a stack is actually working. We can actually make use of one iterator too with respect to every data structure. So let me introduce this iterator by making use on ArrayList. So the ArrayList is having, suppose, 3 elements. And now what I try to do is I make use of iterator over iterator. Suppose I put in as I is equal to al dot iterator. So once you add an iterator over any data structure, what happens that you can actually access all the elements from this data structure using this iterator only. So how this can be done in? So I tell you 2 methods that we basically use in. One method is called as next method and one method is called as has next. What is exactly meant by has next? So we'll make use of, we'll say while al dot has next. It means it returns a Boolean value. So because there are already 3 elements, so what it checks at the start for the first time, it tries to check whether there is any element within this. So for the first time it will remain as true. So once we come inside into the while loop, we'll say your al dot I dot next, and even this has next is also done on the iterator. So I dot has next, till this will be returning true value. it will be actually getting all the elements from this data. So see, what we have done is we have created an instance of this iterator and added an iterator with this array list using an iterator function. So this iterator function creates an iterator over this, and through this iterator value you can make use of these two functions. The first function always checks in whether this array list is empty or not. So it will work on till this is empty and tries to access all the elements from this array list. So let us run this program. I'll show you all the elements of this array list. So we'll see that this actually works on every kind of data structure. So if we make use of linked list collection, so it will work over that too. So you can make use of this iterator over any Java collection. So I didn't make any change. We'll see how it happens. Compile the program and run. See the same output that is coming in. So that means iterator is one functionality that can be added over any Java collection, and that helps in extracting all the elements of a data structure one by one. So this is what is actually stored in Java collections. We'll meet in the next video. Thank you.